Okay, so hello, welcome back to another Unity tutorial. In this video we're going to be doing some more dots and ECS. We're going to have a way so that projectiles can hit a player, deal damage, and then when the player dies they get destroyed. And this system, even though it might require more code than a normal game object way, it means that it's so much easier for us to actually expand in the future. So I'll probably be doing a follow-up video where we'll add blocking or damage resistances, and it'll be so much easier than if we were doing it with game objects. Let's just get into the video, I'll explain it later. So I've split this video up into 3 parts. Part 1 will be the setup, where you guys can see which packages I've got, which versions I've got, so you can, start off at the same part as me. Equally, you can also go download the project from GitHub and just go from there. Step 2 will be components, so we'll be building up the data, so just the data that we need, like the health and the damage and so on and so forth. Then for step 3 will be the actual logic, the bulk of the video, creating the systems that will do all the different jobs that we want. And yeah, that'll be it for this video, so let's get into it. Okay, so for the setup, you want to go to Window, Package Manager. I'm using 2019.3.1 F1, so anything from 2019.3.0 onwards, it should work, though obviously in future releases syntax might change, but for now, we're going to go with this. So Entities 0.6.0, Hybrid Renderer 0.3.4, and Physics 0.2.5. This is all you need. If you have anything on future versions, as I said, stuff might change, but if you're using these versions, then it'll definitely work, okay? That's what I'm using. In the scene, all I've done is I set up a subscene, so I've done that in a previous video, but essentially I just made a plane, just a standard Unity plane like this, and then once you create the plane, you right click new subscene from selection, and then it creates you a subscene like this. Then you can toggle it on and off. So when you turn it off, it gets converted into ECS entities, whereas when it's ticked on, it's open, and that's the same as pressing this close or edit button. So if you go to the entity debugger, which is Window, Analysis, Entity Debugger, you can see, if you scroll up to all entities, all your entities. When I close this, these entities get created, which is stuff in the subscene. Even though there's 3 entities and we only have 1 thing inside, it's just extra things that get created with the subscene. But the reason I've used a subscene is because this thing is static. The floor doesn't move, it's always there, it's part of the environment. So I've put it in a subscene, it's actually converted before I press play, it's already in entities. Whereas the player, I could technically do the same, but I like to be able to just edit it freely and then convert and destroy. So yeah, I've got a player, which is a capsule. Ignore the components right now, I'll add those in a minute with you guys. And then I've got some projectiles above the player that are going to fall and hit them, basically, at 4, 6, and, well, we'll go with 8. Okay, so they're going to fall and hit the player. You're going to want to put on the player the physics shape component, which is the dots version of the capsule collider, or colliders. Then you select capsule. I didn't tweak anything else in here, so I'm going to collapse that. Actually, no, I'll keep it open. The other things, like damageable offering, ignore that for now. We're going to create those in a minute. And then convert to entity you want to stick on, so that when we press play, it gets converted to an entity and destroyed. Then for the projectiles, you want the same convert to entity, physics shape, so that these projectiles, as you see, if we go up here, have a sphere collider on them, so because I've set this to sphere. I've also added a physics body, which is the ECS version of a rigid body, and I've just left everything the same on there. And yet again, with these deal damage offerings, just ignore those, we're going to create those in a minute. But yeah, that's it for the setup. It's simply a scene with some spheres that fall onto the player, okay? That's it. So for this video, I assume you've already got some basic knowledge of ECS and dots, so I'm not going to have to explain everything to you, but essentially we have a health component data, so anything that's the health component, we can read the health value, okay, this is it. We have a tag, destroy on contact, which we can stick on things, and then we'll write a system that destroys stuff when it collides, right? So if a projectile, for example, has destroy on contact, we will destroy it when it contacts with things. It makes sense, right? And then we use the new 2019.3 generate authoring component to create the authoring component for us, so we don't have to write it. We actually use that for everything apart from the health over here, which we'll get to in a minute. But yeah, so that's just a tag we can stick on things to destroy them on contact. Deal damage is also generate authoring component because it's simply a damage value that we can just convert when we in the inspector. So if we drag on the deal damage authoring component, which is generated for us, it'll then get converted at runtime to a deal damage component data with an int value, and you'll see that in a minute when we test it. Then we have a dead component data, which I could make generate authoring component, but there's no need because dead is never added by me. It's always added by the actual code itself, by the system. So I don't need a way to drag it in the inspector. But if you did, then sure, add the attribute and it would work. So we tag things as dead when they are dead, and then something comes along and cleans up everything that's dead. Currently, it just destroys anything that's dead, but obviously later on you can change that logic to be whatever you like. And then over here, the damage component is a buffer element data, which is the one type I'm actually going to explain. So when we deal damage, we might, for example, deal two different instances of damage in the same frame. Imagine you get hit by two projectiles in the same frame. Well, you can't actually simply add like two deal damage components to the entity, because the problem is each component is unique per entity. So a buffer allows us to actually add multiple instances of the damage element to the entity. So imagine you get hit twice, we just add to the buffer two instances of this damage, and then we can store two separate values, which is useful if you're creating, for example, some UI where numbers pop up showing how much damage you've dealt. If you actually want to deal damage twice in a frame, you want to show two different numbers for like you took 10 and you took 20 damage this frame. We can actually add more data in here. For example, if we want to add damage types, we can add that in later, but for now, simply a damage value, okay? And then when we actually deal damage later, we loop over this buffer and subtract all the damage values, okay? It's actually really, really nice. And then finally, the one I closed by accident earlier was the authoring for damageable. So this is my custom authoring component, which is a mono behavior. You stick it on things, and it gets converted. It has this method that gets called when we convert the game object to an entity. I've used this in previous tutorials, so I'll not explain everything, but basically in the inspector, we set the starting health for the entity, and then when it gets converted, we add a damage buffer and a health component. And buffers are kind of components, but they're not exactly the same. And then over here, we initialize the health component to have a value of our starting health, okay? So over here in the inspector now, on the player, you're going to want to stick the damageable authoring, which will then, at runtime, give the player a damage buffer and a health component. And then that's it, to be honest. And then we go over to the projectile. We want a deal damage authoring, so how much damage is it going to deal? Well, 50 right now. And then the destroy on contact, so when it hits the player, it's going to get destroyed, or the floor, or whatever. And then convert to entity, obviously, yep, it gets destroyed when I press play. So right now, our systems aren't working, so the things that's going to fall and do nothing, really. They just fall. They fall through the player because they're a trigger. That's another thing. The projectiles on their physics bodies are, on their physics shapes are triggers. That's one thing to make sure you've turned on. Okay, and one thing I don't think I mentioned earlier was that the floor has a physics shape, which is the same as the old mesh collider, but I've done physics shape mesh, and there you go. Okay, close that. Now we can move on to making our systems. So go ahead and create a class called damage collision system. It's a job component system, as all of our systems will be, and we have to make sure it updates before the resolve damage system, which we haven't written yet, but basically I've just made the 4 templates. I've got the damage collision system, the def cleanup system, the destroy on contact system, and the resolve damage system. Okay, these are 4 systems. There's no logic yet. I've just set them up so that they all exist. And the first one we're going to do, as I said, is the damage collision system. Let's get into it. So because this is a collision system, we're actually going to be needing to access the build physics world and the steps physics world so that we can actually do our collision jobs. So to set that up, we simply store a private one of each, and then in the onCreate method, which is just like an onStart method, but it's for the system. So when the system gets created, we get from the world the build physics world, and if it doesn't exist, we create it. And then same with the step physics world, and we just store them in this system so that whenever we need them in our job, we can grab them from here. Okay, that's the first bit to do. The next thing to do is to make a private struct, and it's for the actual job itself, and it's a trigger event job, which means that obviously when a trigger event happens, when a trigger hits something else, then this execute method is called, and we can actually access from the trigger event the 2 entities that collided, and then from that we can deal damage accordingly. And for this, we're actually going to want 2 things passed in. We're going to want a buffer from entity damage, the damage group, so it gives us access to all the things that have the damage buffers, and then another version, which is all the things that have the deal damage component. Now, and this is a component data from entity of the deal damage. The difference is this is read-only because we're actually just reading the damage value, whereas for the buffer, it's not read-only because we actually write to the buffer, okay? And then now let's write the logic for the execute method. Okay, so there are ways to refactor this. I'm sure you can put most of this logic in a method and just call it in these 2 places. But as of now, we have to basically say if entity A in the collision, if the first entity has a deal damage component, then check if entity B can take damage. Okay, so if A is going to deal damage, make sure that B can take damage. If both those cases are met, if both those conditions are met, sorry, then we say, okay, go get us the damage buffer for entity B. So go get us, entity B's damage buffer, and we want to add to it a new damage component or buffer element data. And then we want to set the value of damage to be the value that entity A is going to deal. And then this if down here is the exact same, but all the entity A's are B's and all the entity B's are A's. And so, yeah, basically we're saying, all right, can A deal damage? Okay. Can B take damage? Okay. Grab B's damage buffer and add A's damage to it. Okay. That's the way I've set it up, and that's how it works. And this, the reason we have it twice is because let's imagine two things that deal damage both hit each other and they can both take damage. We actually want all of this to happen, right? We want them both to take the damage. Two things can collide and deal damage and take damage. Okay, that's it for this system. Actually, no, I'm sorry, that's not true. The last thing to do for this system is actually finish the update method. So the update method will create the job, so it makes a new damage collision job, passing in the damage group and the deal damage group. So it gets the buffer element and gets the component data, making sure to pass in true here because this is read-only, as we said down here. And then finally we schedule the job, okay, with the step physics worlds simulation up here, and the build physics world, okay. Now, equally, you could have cached the simulation and the physics world instead and then said here, like, you know, dot simulation, or what was it, dot physics world. You could have done that, and then, you know, but it still works either way, okay. And then input dependencies that come in here, we call complete to make sure that this is completed, and then we return the input dependencies for the job, okay. Okay, so for this next system, it's just like the previous one. It's another collision system, so we need to take in the build and step physics world, just like the same. And then we also need the entity command buffer system. We're using the end simulation entity command buffer system, which is a way of telling it when to do these buffer commands. So we're going to have to actually write a command to say entity command buffer destroy an entity, because we're destroying in this system. And then we tell it to happen at the end of the simulation. So over here in the update, we actually want to schedule two jobs. We're going to do one job for triggers and one for non-triggers because they collide differently. So it's like in Unity normal where you've got on trigger enter and on collision enter. We want this system to work regardless of if it's a trigger or not. So we'll make a trigger job and a non-trigger job. We get the group just like we did earlier, get component data from entity, destroy on contact. So get us the all the entities that have destroy on contact. And here we also create the command buffer from the system up here. And then we pass those in to these two jobs. We haven't actually made the jobs yet. And then we schedule the two jobs just like we did in the previous system. Make sure to call complete at the end. And then we return the input dependencies. So now we actually want to do the two jobs themselves. We're going to have a trigger job and a non-trigger job. So here's the trigger job. It inherits, it implements, trigger event jobs. And we have the input, the entity command buffer passed in, and the group passed in, just like we do here. And this system's a lot simpler. It just says, well, if entity A has a destroy on contact component, then destroy entity A. And if entity B has an entity destroy on contact component, then destroy entity B. Okay, that's really simple. And then we have basically a copy of that, but for doing collisions or non-triggers. So here it is, the destroy collision job is I collision events job. This is a collision event. And apart from that, it's all the same. We'd say, well, if it's A, then destroy A, B, destroy B. Okay. Now this system handles actually destroying anything regardless of if it's a trigger or not when it has this destroy on contact component. So if we go back into Unity, we go over to our projectiles. Remember, these projectiles have a destroy on contact offering. So now they should destroy when they hit stuff. So they're going to fall and destroy themselves, okay? So we go entity debugger, the projectiles are gone. And you'll notice the player has, in his damage buffer now, 3 elements, 50, 50, 50. So we've not written a system to actually deal with this buffer yet. Currently it's just storing those 3 elements in that buffer. We want to write a system now to loop over here and say, all right, take this 50, subtract it from the health. Take this 50, subtract it from the health. And also it should be checking, well, if the health is now 0 or less, then we should actually count it as dead and clear the buffer, because we don't want to, you know, go to negative 50 health. I mean, maybe you do, but I don't. So we're going to write systems to handle that. Let's get into it. So the resolve damage system is actually going to need to have the entity command buffer too, because what it needs to do is when something dies, it needs to add the dead tag to something. So to add components and stuff, you need to use the command buffer. So we get that in the on create, just like in the other method, okay? And then this system's pretty simple. This system, we don't even need to create an actual like job for it necessarily. It's all done in this one method. We say create as the command buffer, and then we want to query all entities without using burst, because I'm not going to worry about setting that up now. You have to set things up slightly differently. We're going to say go through all entities that don't have the dead component, because we only want to resolve damage on things that aren't dead. So loop over everything that is not dead, that has, well, that is an entity obviously, that has a damage buffer and a health component. then we need to type ref because we're actually writing to these things, and we need to, well, yeah, basically ref is what we use to write, because if we don't use ref and we change health, then it doesn't actually update the health, okay? Then over here we say loop over every element in this damage buffer, treating it like it's a list, and then we want to say, okay, subtract the health value by that damage amount, and if the health is now, you know, if you're dead basically, then set it to 0 because it might have gone below 0, and add the dead component, then break. Don't bother doing the rest of this loop because you're already dead, okay? And then at this point, we clear the damage buffer, you know, we're done with the damage buffer, get rid of it, clear all the elements, and then we run this job here, and then we return default. And the reason we return default is because apparently it's better practice if you're not actually caring about input dependencies in here, to just return default, though this would still work if you return input dependencies, I think. So now if we go over to Unity and press play, you'll see that the player gets hit by the projectiles, and then he gets hit. His health is now 0, and he's got the dead component, but he also actually still has one element in his damage buffer, which technically shouldn't be there. So the way to resolve that is to say, don't actually add to the damage buffer if it's already got the dead tag, because what happens is we kill it with 2 projectiles, and it's dead, but then the third one hits and it just adds more to the damage buffer. We don't want to like be getting damaged when we're already dead. So to do this, we should head over to the damage collision system where we add to the damage buffer. Here we go. And we should basically say we want to get all the things that are dead. So we'll say we want a public component data from entity dead group. And this is actually also read only. Okay, read only. Then if we head up here, we want to pass in here the dead group equals get component data from entity dead group. Well, sorry, what am I doing? Like this. Pass in true and a comma. So now we can check, well, here, if the dead group dot exists trigger event dot entities dot entity b, then we actually don't want to do this, so we'll say if not, and we should actually wrap this around the we don't want to check if it's damageable if it's already dead. There's no point, right? We don't really care at that point if something's dead. So take this out and just shuffle around the brackets a bit, and I've clearly messed something up here because this should be here. There we go. So we say, okay, you know, can this projectile deal damage? Does the other thing, is it dead? If it isn't dead, then, you know, can it be damaged? And then we actually do the final thing. And then it's the same over here. Obviously, we should check before this. And then after this, we do a close. And we just say if dead group entity A. So when we've done this, when we go back and check in Unity, what should happen is if we press play, give it a second, we should get hit by the projectiles. We go to the player, and the player now in his damage buffer doesn't have any elements, and he is now dead. Equally, we could actually just remove the damage buffer. You know, it's up to you whether you clear it or you remove it. I think it's actually better not to remove it performance-wise, because it affects the chunk layout, but well, the archetype layout. But yeah, that's it for that. One more system, which is the actual def cleanup system, which will effectively kill the player when he's dead. Okay. So the def cleanup system also has the end simulation entity command buffer because it needs to destroy entities when they are dead. And finally, for the actual update method, what we need to do is we just need to say over here that, or create the command buffer and loop over everything that is dead, okay? Everything that's dead, and then destroy the entity, okay? That's all we want to do. We want to destroy anything that's dead. We could actually put the dead component in this query, which would still get us the same results, but it's actually more efficient to say this because we don't actually need the dead component. We don't need to access it, so we don't put it in the actual query. We put it here, which still gets us everything that's dead, but it doesn't have to pass us any data about the component or anything because it's got no data on it, actually. It's just a tag, right? Okay, we destroy everything that's dead. Now, silly me, I've just realized because we kill everything that's dead because we remove it, we don't actually need to check back here about the whether it's dead or not, because if it's dead, it can't be hit, right? It doesn't exist anymore. So with our implementation anyway, we don't need that. So we can actually get rid of the dead group and do it over here too. And with this, everything should be working now. So if we go back over to Unity for our final test, we'll notice that when it runs and when the floor reappears, it's just a rendering thing as it's sorting itself out. the balls fall and they hit the player and they die. You notice the player actually died after the second hit. He died when he should have, basically. So if we press the pause button, go back to the game view. So we've got one element hits, and if we go to the player, 50 health, and then we go down to 0 health, and then the next frame, it gets cleaned up and he's dead, and then that ball hits the floor. Okay, so there we go. We've got our damage system using the buffers, destroying things when they die, destroying the projectiles when they collide. That whole thing's set up, and the best thing about this in ECS is the fact nothing knows about each other. Everything is isolated, so that we can easily remove one of those parts, and we get no errors. Nothing will, break if we just delete a system. Technically, it will require us to change, for example, if we have a requirement to update before a different system. If that system goes, then yeah, we'll have to just remove this line, but that's the most you'll have to do. Right now in Unity, if you have references to other systems or other classes and then remove that class, you got to remove your references and change loads of code. But with this, it's really easy. You can equally just turn off systems when you're testing. You can disable systems, and also when we come to write a new system now, we can just stick it in the system, in the loop. For example, the damage resistance system. For damage resistance, we just need to update after damage has been added, but before damage is resolved. So if we update before the resolved damage, we can actually tweak the damage buffer's element. So we can say go over everything in the damage buffer and reduce everything by 10. Then by the time you get to the resolved damage system, all this cares about is how much damage am I left to deal now. Okay? So we're going to do another video on this, maybe in a few days, maybe next week. But yeah, I hope you guys look forward to it. If you enjoyed the video, then leave a like and subscribe. It'd mean a lot. Thanks for watching, guys. I'll see you next time, and goodbye. But of course, before I end, I've got to thank my patrons. A special thanks to Josh Folsom, Beard or Die, Dustin Miller, Francisco Diaz, Rack, Yorasleta, Hades Orko, Rene, and Marie Baldwin. If anyone else is able to help support the channel monetarily, link to my Patreon is down below. If not, there are also links down below to other social media, such as Twitch, Twitter, and Discord. If you could help us out by following on any of those, it'd be greatly appreciated. I'll see you guys next time. Thanks for watching, and goodbye.